Ibadan is a mega city and one of the largest cities in Nigeria. Ibadan, being the largest city, is also known as the largest indigenous city in sub-Sahara. It is densely populated. It is a densely populated city with numerous distorted land use plan. And in 1911, the estimated population was 175,000, which has increased to 2,550,593 as at 2006, according to National Population Commission. The city is characterized by lack of proper sewage, unplanned urban setting, high traffic density, and indiscriminate disposal of waste, liquid and solid. Objectives of the study. The work is to determine the mineralogical and trace metal contents of the sediments, to evaluate the pollution status and identify the possible influence of land use and human activities on metal concentration. The materials he used were stream sediments. A total of 233 stream sediments were picked. He also had about 4 streams that he worked on. He worked on Omi River, Ono River, Ogunpa River, and Ogbere River, all in Ibadan metropolis. Then he did some mineralogical analysis, XRD, ICP, and sequential leach. The study area, as I had earlier said, is drained by rivers, River Omi, River Ogunpa, and River Ogbere, and I'm looking for the pointer. Okay. Yes. So, River Omi, sorry.
Try second one.
It's not sure.
Because are not working. Excuse me. We need a pointer, please. Pointer is not. Yes, pointer.
Yes, the pointer is not coming up. Well, River Omi, that's the first one, the dark one, followed by River Ono, the green one, River Ogunpa, and River Ogbere. Okay. So those are the 4 streams he actually worked on. River Omi had plant agricultural streams or creeks flowing into it, where they would do fishing and plantation, basically cocoa plantation is being done there, and all the runoff water flowed directly into that stream. River Ono has industrial effluents. Like I said earlier, one of the main problems in the city is indiscriminate disposal of waste. And because there's no regulation, there's nobody that will catch you, we said there's no place to put it, just drop your refuse anyhow. So the effluents, industrial effluents, flow directly into River Ono, where he also picked some of his stream sediments. He also had, he worked on River Ogbere, the 3rd river, and that one is mainly, we call them the new city center, where bricks are used to build houses, and well, it's part of the modern area in the city. They didn't put the 3rd one, the 4th one. The 4th one is River Ogunpa, where he worked on, and that one is basically on the old area. This is an example of the old, okay? That's the area view of the old area, where we have modern houses, unplanned area, people living very close to each other, a lot of houses not having toilets, people doing what they like, and so the water, the runoff water just flows directly into River Ogunpa. Now, the mineralogical data that was done on the rivers showed that high kaolinite, illite, chlorite were dominant, especially kaolinite and illite were dominant in rivers Omi and Ogbere, and quartz was found to be dominant in rivers Ono and Ogbere. He also did sand clay content analysis, and for the analysis, the main value showed that River Ono and River Ogunpa had high sand content. Now, he tried to compare the elements of about 4 different streams, which he picked areas where he picked his samples. He picked upstream, in the middle, the midstream, and the downstream, and he also had control. And for River Omi, there are a lot of community populace. So at River Omi, this place, the midstream was shown to have high metal content. And this particular area is heavily populated, heavily congested. And like I said earlier, River Omi has agricultural influence flowing into it. So for it has high metal content at high, where the environment is highly densely populated. Now for River Ono, he divided it into the area into agricultural, industrial, mechanic refuse area, the residential, and of course the control. And for this, the mechanic area was found to have high influence, basically because of the indiscriminate disposal of our refuse, both liquid and solid waste. And the mechanic village, the mechanic village also doesn't have any major regulation. So the mechanics just drop things on the floor anyhow, and they do their own work the way they feel they should. For River Ogunpa, that is flowing, that is found in the old area, unplanned area. This part, the Iso part is known as the area where we have a lot of market people, where we have a lot of carpenters, where we have a lot of different people doing different things there. So it was this area that was found to have high metal content. And for River Ogbere too was found to have high metal content at the mechanic section. Geochemical evaluation revealed that River Ogunpa, which is in the middle, and River Ogbere has high metal content compared to the 2 rivers. And also for zinc, it also showed the first one was for lead and the other one was for zinc. For zinc, it also revealed that River Ogunpa has high metal zinc content flowing into it. The factor analysis showed River Ogunpa to also have high metal content, confirming it. This is the factor plot. And the pollution index, for the pollution index, you can see that for River Omi, this one was decreasing, but it has a particular high metal content, pollution load at the industrial area. And for River Omi, it was a bit high at the agricultural section. For River Ogbere, it was found to be high at the agricultural and refuse section. And for River Ogunpa, the high pollution load was found at the old city area. Comparison was done between the mean concentration and pollution load for all the rivers, and River Ogunpa, which had the influx from old city center, was found to have the highest copper content. Invariably had the highest metal influence compared to all the others, followed by River Ogbere. So this is the geochemical index, which is confirming what I said earlier. And this is the sediment fraction, also confirming the metal content, especially for River Ogunpa and River Ogbere. Now, the sediments was now compared with a guideline. It used a guideline, the TEC, the threshold effect concentration, the PEC, probate effect concentration, and the Canadian sediment quality guidance were used to check the pollution rate of these sediments in each of the rivers. And of course, for virtually all the rivers, they were found to be above the guideline, especially, and that of Ogunpa was found to be quite high, except for cadmium, that was a bit low. Even though it was a bit low, but all the other metals were found to be high while comparing it with the standard guidelines for sediments. Now, the lithogenic and anthropogenic contributions of metals were also done, and it was revealed that the enrichment of copper, zinc, chromium, cobalt, nickel, and arsenic in the sediment attributed to the anthropogenic sources found in the environment. And high concentration of copper, lead, and zinc is in agreement with the earlier discovery of Odewande and Abimbola, which was due to road dust, outdoor and indoor particulate matter, soils of urban city. In conclusion, weathering and land use, coupled with urbanization, pollution density, human activities had contributed to the pollution load found in areas in these rivers, especially River Ogunpa. Toxicity of sediments has occurred in River Ogunpa, which is the old city center, due to the old city center that is draining its channel directly into the stream. Anthropogenic metal enrichment is found to be greater than the lithogenic metal enrichment in sediments derived from the drainage channels. Copper, lead, zinc, cadmium, and arsenic dominates the bioavailable sediment fractions. Efforts should be made, that's a recommendation, to reduce pollution level through mitigation. Thank you for listening.
Okay. Thank you very much for this good presentation. And I would like to explain, did you make analysis for river water or for sediments or for both?
The sediments all are from streams, from rivers.
Yeah, you analyzed the sediments only on the river.
Yes, he did, not me. I'm just presenting on his behalf, yes.
Yeah, what about the concentration of these metals in water?
Yeah, he didn't work on what I only did for stream sediments.
Yeah, sediments in the banks of the river or sediments in the flow?
Picked from the upstream, the midstream, and at the back of the river.
Yeah, okay. So I think it was better if you make analysis for concentration of these metals in the river, in water in the river. Okay. And you can just for comparison or for what expecting. So what do you expect is the source of this element? Because you mentioned the high concentration of lead. What are the dimensions used in determination? Because you mentioned numbers without dimensions, without units. For instance, 6 for lead. So yeah, bring any table and just show the numbers exist in the table or in this figure. So what are the dimensions of this? It was 500 and 600. Is that ppm, milligram per kilogram, or what dimensions?
Sorry,
Yeah.
I'm just presenting.
Yeah.
I think it should be in milligram per
Yeah,
liter.
it is very important to
Yeah.
to mention the dimensions, the unit. It is very important. Otherwise, we can't confuse, because it is high concentration, high content is of copper, zinc, and lead in your sediments. So, what do you expect is the source of this metals?
The main source of these metals, from my own work, from my own idea, is of course anthropogenic.
Yeah.
The anthropogenic is partly one, the effect of the mechanic environment. The more we put oil and different things on the ground, it affects the soil, and so that one is part of it. Then the refuse environment. Like I said, the environment is filled with indiscriminate disposal of refuse dump. So different things. We have copper, steel. We have different materials that are used for copper. Different things that changes into copper in the earth that affects the environment. So the main source of copper, lead, and zinc pollution in the environment is anthropogenic. It is man-made in the environment.
Of course, it is anthropogenic, but is that in industrial activities or sewage sludge, sewage effluent? The discharge sewage effluent in water, or from
what I'd said, the mechanic village, it's a particular village that is quite big, so I could call it an industrial influence in the environment. So of course we have our industries, but it's a mechanic village. It's quite big, very bogus. So it is from that village, it's affected, and of course from the water runoffs that flows. It also affects the soil in the environment.
So, did you make a comparison between the polluted area in the river stream and another unpolluted area?
Yes, this is the control.
It is better because metals could be maybe origin, natural origin. Could be natural origin, could be anthropogenic activities.
Yes,
if you made this comparison, it will be very good for your research.
He had control.
Yeah.
So, he had control.
Just move the block.
The main challenge of urbanization in developing countries, especially Nigeria, just like I said, is accessibility to good potable water. And this is being reinforced by uncontrolled population density, inadequate hygienic infrastructural facilities that we had seen earlier, with no actual waste dump sites. What we had seen earlier, dissolution of organic matter, infiltration of rainwater into the refuse pile, which then lead to leaching of soluble metals in form of toxic waste into the groundwater. Persistent discharge of this waste led to high contamination. Groundwater quality degradation is related primarily to what the land is being used for, and this could be industry, agricultural plantation, mechanical workshops, and many others. Groundwater contamination is associated with man, and this occurs from different sources. From where I worked on, it can occur from chemical and waste dump sites, which are confirming what I had said earlier, that we had uncontrolled disposal waste. It could also come from sewage pits. It could come from burning of fossil fuels, waste incineration, and high water runoffs. Most of our markets, we don't have a special market, that this is a market that you have. We have unplanned markets, which uncontrolled water runoffs in all the area. And contamination can occur also from industrial areas. Like I said, I worked on zones. That particular area was divided into zones. Part of it is this area that I call the industrial zone. What they do basically is to make tie and dye, something like what I wore, and it's a very big community, and that is what they do. And with this production of tie and dye, it's a way of living for them, and this can cause contamination because of the chemicals that are being used, that were allowed to flow in an uncontrolled way, basically as runoffs into the environment, thus affecting groundwater. This is one of our hand-dug wells, affecting groundwater through leaching, and of course, it gets into drinking water. The elements get into drinking water, causing deadly diseases, such as cholera, dysentery in man. Justification of the work is done. The work is done due to the toxicity and health impact, to check the toxicity and health impact. And the research work was focused on the impact of contamination on groundwater of different zones. Information about this kind of work in our environment, in my own particular environment, is a bit scarce. The objective of the work is aimed at assessing the impact of anthropogenic activities on groundwater in the crowded market, in residential and industrial zones. Those are the four main zones the city was divided into. I just picked a particular city. I divided it into industrial, the crowded, the market, and the residential zone, and also to determine the source of groundwater pollution in the study area. Now, the study location, I picked Abeokuta. Abeokuta is one of the cities in Nigeria, and it is found in the state, Ogun State. That's where I work. And the area, Abeokuta, was divided into 4 zones. The crowded zone, I used red for it. This is the crowded zone. And the industrial zone is the blue, and that is where the tie and dye is. The market zone is the yellow. The residential zone is the green, and the control. And we have the rock types found in the area are bautite gneiss, porphyroblastic gneiss. They were found basically in the area. The study design. The study was divided into zones. The industrial, this is the industrial. This is the woman, one of the women working on tie and dye in the environment. The market zone. This is our market. This is the water runoff, the major activities, of course, selling and buying of foods and different things. And of course, they don't have any major channel for their drain. The crowded environment, where most of their hand-dug wells are uncovered, uncased, and then the residential environment. Different analytical works were done, and determination of factor indices, my factors and indices. I use the contamination factor, geoaccumulation, and degree of contamination for the analysis before I now got the result. Now, with the result, I first compared the mean value of all the metals with the TDS, EC, pH, with the WHO, EPA, and so on. And interestingly, for all, the mean contents of these metals were found to be within this, the standard. The SON is the Standard Organization of Nigeria, the World Health Organization, and the Environmental Protection Agency, except for the potassium that was found to be a bit high in the water, in all the groundwater that was analyzed. Contamination factor was now done for all these zones to classify the level of contamination of metals in the environment. And it was, contamination factor used was according to Atkinson, 1980. And for this, if it is higher, a bit higher than 1, it has a low contamination factor. And if it is between 1 and 6, it is moderate, it has a moderate contamination, and if it is between 3 and 6, it has a considerable high contamination. And all the elements have a contamination degree of less than 8. So now the contamination factor that was done for industrial, for lead, was found to be a bit high, 0.2. And for sodium, for calcium and magnesium. And for markets, for the market zone, it was found also to be, lead was found to be high for industrial, market and crowded, sodium and ditto sodium, calcium, and magnesium for industrial and market. Geoaccumulation index also was just to use to assess the rate of contamination of the area. It's just to check it with the contamination factor that was used, and it was found to be a bit high in the industrial for cadmium and lead. And now this is the box plot just for the metals in the environment. All the works were in ppm for the environment, and it's for the industrial, where tie and dye industry was found, the market zone, and the crowded zone. But the interesting thing, part of the work, was that the residential zone that was supposed to be relatively okay was also found to have high calcium and sodium in the groundwater. And of course, a control was made for these zones, and the work was confirmed that the work was not coming from the geogenic source, but rather it was coming from anthropogenic influence on the groundwater. And the main reason of this source was because of the way the water, the effluent, or the way it runs into the environment in an uncontrolled form. And in conclusion, it was realized that the effect of these metals is becoming a major problem, it's now giving the environment a high, the public high impact. And most of the environment, people living in the industrial environment are more in the hospitals now with water, with a lot of waterborne diseases, and of course for the market, ditto the market and the crowded zone. So my main recommendation for the work is for the environment to be well organized, to be well arranged, the government to have a major strict and disciplinary measures for the environment, so that the environment could at least be clean, and of course for refuse dump basins to be placed for in different communities, so it becomes easier. Because one major problem in that our community or in the city is because the government had not actually provided a major place for them to put the refuse, so everybody feel, since I don't have a place to put it, where should I put it? There's no one to come and take it. What do you want me to do with it? I can't put it in my house, so I throw it outside. So if there are different dustpan or big ones for each community, and there's a regular way of disposing them, then there's a good way of reducing the impact, contamination impact, anthropogenic impact on groundwater, because most of the problem found is anthropogenic impact of this element on groundwater. And all the groundwater, basically the groundwater is what the people take in, and that's what we use for drinking, bathing, and so on. So I'll stop here.
Okay, thank you very much for this explanation. And yeah, I think we can say we really live in the century of evolution. Okay, so let me ask you for two major comments in your work. Do you remember table number 1? Table number 1.
Yes.
In table number 1, the title was trace element concentration. And in this table, you write down potassium, calcium, and magnesium. Do you think potassium, calcium, magnesium are trace element?
They are major elements.
Yes, yes, they are not trace element.
They are
So
major
it is,
elements.
yeah, it is better to change the title of your of this table. It is very important for you. Otherwise, anybody reads this, so it will get not good impression about. You did very good work, but it just need. And also in table number 2.
Okay.
Do you remember table number 2?
Yes, for
In
the
table number 2, you mentioned contamination, and also you write down calcium, sodium.
yeah.
So calcium, sodium are not contaminant.
Yeah.
Contaminant means what? An
Trace
element
elements.
does not exist in the media, and when it get down to this media, it is a
It
contaminant.
becomes
And also,
toxic.
you know, big difference between contamination and pollution. So you have to take care
Yes.
for the title and what is get in the contents of the table. It is very important, and it is a very good presentation, very good work, and I hope you good future in science, inshallah. Okay, and you, Dr. Kumshunk, would you like to continue your speech?
I would like to add something. It seems to me that it is.
Yes, open the mic. Give it to me.
It seems to me it is possible to indicate some points of pollution with remote sensing methods. For instance, Google Earth gives very good photos of high resolution, where you can see an object about 1 meter. For some regions. I don't know whether your region is covered by these photos, but I think it is possible to find something like this. And it will help to resolve the problem of pollution.
Thank you, sir.
Okay, who wants to give us? Okay. Okay. No problem.
Now, actually both these articles very clearly show that the anthropogenic activity is very severe, which is causing a great pollution both in surface water as well as in groundwater.
Yes, sir.
Isn't it? Except is this a scenario in the entire Nigeria or only in pockets?
I would say it's a major, that's the main scenario in Nigeria. Because lately we had mining, artisanal miners. We have a lot of artisanal miners in the northern part of the nation. And lately there's a particular area in one of our states, Zamfara State, that the influence had actually affected the soil and water, and lead in particular is now given, had caused a major epidemic in the area. And now people living in that village had been evacuated. So I'd say that the main source of problem is anthropogenic source in the
No, is this known to government? Is this known to government that this much of pollution is going on and the people are taking only the polluted water? And both surface water is also polluted and groundwater is also polluted?
Well,
is it known to them? Known to government, or has it been brought out to government?
Well, I'll say I don't want to. Well, it's not that they don't know. It's not that the government does not know, but well, we just need God's intervention, because, like, the government is doing more where they shouldn't and living where they should, and when it becomes a problem, that's when the government steps in.
Somewhere it's a very serious issue, not only with Nigeria, but all over the world. Most of the rivers are polluted and the aquifers are polluted. But unless otherwise a scientific movement has been initiated, that too in this part of the less area, least rainfall area, it is further expected to contaminate more and more. Groundwater system is expected to contaminate, and at one point of time it will become totally undrinkable. So unless otherwise a scientific movement has been taken place, has been initiated, I don't think that this problem could be solved. Whatever algal and then your microbes that could be done, probably the way the pollution is going on is great. That must be much above the threshold capacity, carrying capacity of the microbes. Microbes and then even cyanobacteria and other things, if you culture it, even that stage you have crossed it, unless otherwise the pollution on the spot is arrested, probably, and then you must force the people to recycle the water and then send it, let it inside. Otherwise there is a strict control. At the maximum we can bring out only this type of status report we can bring out. But unless otherwise a big scientific movement is initiated, it can't be stopped.
Yeah, like now, one of my co-supervisors, Professor Shrida, is also an Indian. He co-supervised my work. He had started this community work, and he's mainly on recycling of waste and going for seminars, and so it's in the public health section, and so gradually the thing had started, and of course it's now becoming a major awareness in the states, in the nation. So that's
regarding mapping, as he said, of course the high resolution pictures from QuickBird and other things have come up now.
Okay.
That again will give only the status mapping. Probably that may reduce the strain what you are facing by ground survey and other things. You can develop some models which you can keep on forecasting the quality of the surface water.
Okay, sir.
That is possible, that the quality sensors have come now. With the presently available sensors, you will be able to periodically forecast the water quality. Level of contaminant you can tell. Level and the type of contamination also you can tell. Broadly, but the thing is now how you are going to compact it, how you are going to mitigate it, that is the biggest issue for which you will have to come out with some idea to government, and then this is how it has to be done and all.
Okay.
Otherwise it's a very serious issue where what every human being has got a concern over it.
Okay, thank you very much, Dr. Ramsamy, for your good comments and for your good audience for the session. And what about our intelligent students? Would you like to give us any comments about the presentations of today? You can just give us what is your impression about the presentations of last session or morning presentation. Would you like to say something? Okay. You can. Okay. Take the mic and just give us few words if you would like. If you don't like, yeah, it is okay.
Yes, I like the presentations very much. It began with the applications of nanotechnology. Yeah. It was very informative. And whatever presentations we have just now, what we have from Nigeria was very informative about the geochemistry of pollution in Nigeria. So as a student, for me it was standing on an international forum and getting the information on various subjects, getting exposed to the recent advances in the various fields. So for me it was a very nice series of presentations. Thank you.
Okay, thank you very much. Is anyone wants to add something or to speak? So you can sit down. Yeah, you finish your job. You can sit down and take your